Hey guys, we're Team 8 for Fluid Mechanics EME 303. Our topic is bouncing droplets on hydrophobic surfaces such as the surface of water. So here's a group of scientists using a slow motion camera to capture the movement of a water droplet bouncing.
But in his lab, Bush and his team have devices to slow down time and get an unprecedented look at what's normally hidden. These specialized high-speed cameras shoot 10,000 frames a second. They can capture images 400 times faster than the human eye.
And just an object hitting a water surface is very complex, and one sees higher and higher levels of complexity with faster and faster cameras. The goal here is to see something that no one has ever seen before.
And what Bush sees is astonishing. Water doesn't do what we think it does. When you pour water into water, the last droplets do a very quick but amazing dance. It's invisible in human time, but we can see it here. Scientists call this phenomenon the coalescence cascade.
You take a drop of water and you place it on a water bath. You ask 1,000 people and 999 will say simply goes like this. It basically merges with the underlying bath.
Exactly half of the droplet disappears into the water underneath. The other half becomes a smaller droplet that shoots back into the air.
And then it dumps its contents again, and now a drop of a quarter the size jumps up, and it keeps going. We've seen as many as 7 such events in a coalescence cascade.
The water droplet acts a lot like a bouncing ball because the hydrogen and oxygen atoms have an especially strong bond.
Based on observations made in the video, we feel that surface tension is the main cause of why the water droplets bounce when they make contact with the surface.
So before we look at the mechanism behind the water droplet bouncing, we have to first take a step back and actually analyze what surface tension is. It's a contractile force that resists change in shape, and for our case, the water droplets form a shape of a sphere to minimize the energy that's being released every time it bounces. It's also caused by the cohesive forces of water. So water is a very cohesive fluid. So surface tension is caused by the water molecules wanting to stay connected to each other and not dissociate into a splash of water. In our case, the surface of the water is very hydrophobic at that instance when it's bouncing, because the surface of the water acts as a solid at that one moment in time. So we're trying to analyze that aspect of water in this case.
Even though surface tension affects how the water droplet bounces off a surface, we also found that contact angle contributes to a degree to how the water droplet bounces. And the contact angle comes from a force balance among the interfacial tension as defined by the following equation.
So in the first part of our analysis, we just briefly had a discussion about surface tension, and with that analysis we were just looking at the water molecule itself. But with the contact angle equation, we take a step back and we look at the entire system, with the water droplet, the surface of the water, and the air that the water droplet is falling through. And as we see from this equation, all three of them have an effect on the force balance equation. And as you can see from this equation, the net force is pointing up, so that it does drive the water droplet to move up. So
for our conclusion, we realized while the surface tension does play a role in the phenomenon of the water droplet bouncing, we also realized that the surface tension between the water and the air and the surface and the air also contribute to the droplet bouncing.